I am Jason Marsh. I am CEO and technical founder here at Flow. We're also really interested in finding great partners like yourself to make sure that what we're building is real and usable and meets real world use cases and provides end value. We are not trying to build something because it's cool. We're trying to build something that gives people mastery and control over their data, over their environment and their information. So this is using the Oculus Pro in mixed reality mode. And what we're going to talk about is El Nino. We're going to talk about climate, which I just am using as a reasonably robust, complex data set. And as you guys know, this is just one of the many, many different data sets and use cases you could think of for Flow. So without getting into too much detail on the content, I do want to tell you a little bit about it, so it'll just give you'll understand the meaningfulness of what we're trying to accomplish here. So what we're looking at here in this first view is sea surface temperatures in the South Pacific. This is the El Nino, essentially. And you'll notice that the white line is the average since measurements were taken starting in 1950. Each one of these rows is a full year. So you start with January to December, and you can see, first of all, let's just notice the green line here is from 2016, 2015 in the back and 2016 in the front. And that was the last El Nino year we had. And this is 2023, the yellow line. And you can see that it's really off the charts compared to anything we have seen. So what does that mean? Looks like we're having the start of a very strong El Nino. Let's look at this in a couple of different ways. So what I've done here is I've put the data going back over time based on months. So we can actually see what were the most extreme temperatures for certain months. And it's pretty clear here, right, that these last few years have been incredibly warm compared to the history of the timeline. But also notice that these really warm months were in 2016. I've neglected to mention that we're looking at the Northern Hemisphere anomaly temperature. So what is different from the norm if the norm is defined as 1900 to 2000? So let's get into the ChatGPT part of this. Put this on a 2D radar chart. So what I'm going to do is, using our template system in Flow, have ChatGPT take a look at the data, take a look at the columns, and figure out which chart to apply it to. In some of these cases, I can just say, visualize this, and it will pick an interesting view, and you can ask it to put it on a different way. What we've done here is we've mapped each month around the circle, and the distance from the center is the temperature. And again, we've labeled the maximum temperatures. And again, it's kind of wild to see how far outside of norms some of these temperatures were in 2016, but it's still pretty flat. So let's make it a little bit more interesting. Put this on a 3D radar chart. So we're going to expand it out. So wow, here it is. It's a tornado. Again, it's the same radar chart, but what we've done is we are now looking down it, looking back in time. So you can really see the shape of the structure. We've taken the temperatures from 1950 to the present. And this is again, we're looking at global land anomalies. So how far off of the norm are we, with the zero line down here? This is pretty clear. And so what we've done is we've colorized these temperature increases based on the El Nino, La Nina cycles. So we can, isolate, say, show me the last very strong El Nino. Turns out that was 2016. Remember, we keep seeing 2016 in all those prior views. And over the last almost 2 years, we have had a very long La Nina, very unusual. You see all the other La Ninas usually last about 8, 10, maybe 14 months. This has been some 22 months of La Nina. Again, La Nina means these are cooler temperatures in the South Pacific, yet we've still had a couple of the warmest years on record. But look at 2016. That's the crux of this. Let's get some little bit more information about this. This is just now looking at the temperatures in the South Pacific over time, monthly data. Tell me how this affected Mongolia. So what we've done is I've selected one of these months. It's actually a midpoint representing a 3-month period, because that's the way that ONI, the Oceanic Nino Index, works. It's recognized my voice. It's going to use that data point as context, and it's going to tell me that a strong El Nino in December, January, February period of 2016 caused severe drought, leading to a shortage of water and food for both humans and livestock. With ChatGPT, we could have asked it about anywhere in the world. I will say that, yes, this is using ChatGPT's global knowledge, but we have already experimented and trained the responses to be built from internal reports. We assume that the use case is probably more going to be that you have experts, you've been spending a lot of time doing a data analysis, you have these data sets that get lost in some boring PowerPoint, oversimplified, without helping your audience really build the good mental models they need to drive good data-driven decisions. And in this case, you can see the data, you can have that good conversation, and with ChatGPT, you can pre-populate the answers and queries based on hundreds, thousands of pages of internal content, so that you have this expert visual assistant to help give you context for the information. What is the Oceanic Nino Index? So another thing that we can have it do is actually create the conversation in 3D space around us. I'm just talking to it myself without other people in the room, but also in a collaborative environment, someone could say, well, do we know the answer to that question? And just start asking ChatGPT those kinds of questions. We can see that it's going to tell us that the Oceanic Nino Index is part of a suite of climate indices. What is it used for? And how is it calculated? What I've done here on this almost last step is to put the land temperatures on one axis and the ONI on another axis. And what is particularly interesting in this example is, yes, you can see the relationship between that very strong last El Nino and the temperature. You can also see that we have had quite high temperatures globally, even though we've had cold temperatures in the South Pacific. This is an inverse relationship. And as we take a look at what's happening, again, back to our first visualization, this is the way this El Nino is developing, points to record high temperatures globally coming this fall and maybe next year.